Very good morning to all of you. And I am Deepankar Ghosh. Again, welcome you to Production Technology class. In this previous classes, already we completed your resistance welding processes like your spot welding, projection welding, seam welding, butt welding, and these are all goes under resistance welding process. So after completing your resistance welding process, let the next article as per your syllabus is a long question and which is known as tungsten inert gas welding. In short form you can say TIG welding, TIG. So first of all, what do you mean by TIG? It is an arc welding process where joint is produced by hitting the job with with an electric arc struck between a non-consumable tungsten electrode and the base metal. So this is the definition as per your definition. Here welding is performed in presence of shielding gas, that means you can say inert gas, so that the atmospheric contamination of oxygen is not creating any problem to the welding surface. So shielding gas, these are we are using as inert gas, and you know argon, helium, nitrogen, these type of gases we are using to avoid atmospheric contamination of the molten weld pool. So tungsten inert gas welding is commonly used a high quality welding process where precision is required. Actually, before we completing arc welding, already we completed arc welding, gas welding, but in TIG welding, it is a very precision welding process because whatever the workpiece we get, used by your TIG welding, these are very high standard and high quality as well in the shape of strength. So in TIG welding, an arc is formed between a non-consumable tungsten electrode and the metal being welded. In TIG welding, we are not directly used as flux, but we are using an inert gas cylinder. So go to the next cylinder. These are the equipment list of TIG welding. Here we are using, this is as we already discussed, we are having an inert gas supply chamber. That is, this cylinder is contain inert gas, either may argon, helium or nitrogen. From there you are having a regulator in this place, and by using a hose pipe, it is directly connected to a electrode holder. Here we are having an welding machine, that means you can say the welding power source or an welding transformer, from where just like your arc welding, the negative pole is connected to the workpiece and the positive pole is directly connected to the electric holder. This you can say torch, where the inert gas supply is there, and here is the place of your workpiece. And because we are using a tungsten electrode, this electrode is a non-consumable electrode. As we know, already we read about your types of electrode. We are having consumable electrode and also you are having non-consumable electrode. So in TIG welding, the electrode what we are using to generate the spark, it is basically a non-consumable one. So here in this case, the electrode is not going to consume. This is the equipment assembly. So next we go to these are the components used in tungsten inert gas welding. The following components are necessary to perform tungsten inert gas welding. So first of all, inert gas supply cylinder is there, power supply, either it is maybe AC or DC, and a non-consumable tungsten electrode, inert gas supply, filler rod. The filler rod is optional one. Either you can use it, it will depend upon the nature of the workpiece, and the welding head, that means the shielding your sub safety equipments. So let us discuss the working principle of working. So, first of all, the welding current and inert gas supply is turned on. Thereafter, the arc is struck by touching the electrode with the base metal and then separating at a distance of 2 to 3 mm. First of all, just like arc welding, we struck the electrode to the workpiece and thereby intentionally create a gap of 2 to 3 mm so that the arc can be generated. Thereafter, the non-consumable tungsten electrode is held in a special electrode holder which also carries a passage around the electrode for the flow of inert gas. Then the inert gas provides a protective shield around the weld pool and protects the electrode, molten metal, the arc and adjacent heated area of base metal from atmospheric contamination. Then the intense heat of the electric arc produces the required welding temperature for fusing the metal pieces and melting the filler metal if required. The electric arc is moved along the joint to heat the base metal and the filler metal which is positioned within the inert shielding gas zone. The molten droplets of the filler metal are deposited at the weld pool of base metal and on the cooling a solid strong weld is produced. So this is as per your, first of all, if you go through shortly, we can say first of all we have to switch on the gases, thereafter we switch on the transformer. As we know, the negative pole is contact with the workpiece and the positive pole is go to the torch. So as we are using a non-consumable tungsten electrode, so first of all we have to struck the workpiece to the electrode to the workpiece and thereby intentionally creating a gap of 2 to 3 mm. So we can say the arc is generated, and due to that arc the parent material get melt along with the filler material, and we know the filler material is an optional one. If you require it, then you can use. If you don't want it, then you cannot use it. So you can melt the molten metal. Therefore, what's happened? The fusion takes place, and when the parent metal get fused, after it create a weld pool, and after you allowed it to cool down, a solid weld is formed. So next, so this is how the working of the tungsten inert gas welding. So let us discuss now the advantages of tungsten inert gas. So the tungsten inert gas welding produce high quality weld. That means it produces a high quality weld. The weld is automatically protected by the inert gas during welding process. Number 3, no slag is produced in the TIG welding. Last one, TIG welding can be done in any position. That means in vertical position, you can weld in a horizontal position. So these are the advantages of TIG welding. And another thing is, plate up to 6.4 mm can be easily welded by this method. Here it is not written, but it is also the fact that up to 6.4 mm thickness plates, which is very difficult to weld in other welding process, by if you use your TIG welding, then it can be easily easily welded by this method. So these are the advantages. Disadvantages also, tungsten inert gas welding is a slower process because you know the gas flow rate is slow, and it will take some time. Welding time is high, so it is production rate is quite slower. Highly skilled labor is needed for tungsten inert gas welding. Skilled labor is needed. Welding is exposed to the huge intense of light. It produces light, so you need some protective devices like you needed some protective devices as a safety point of view to your eyes. Again, TIG welding is more expensive when compared to the MIG welding. in the later on we discuss about another welding process which is named as MIG welding. So